Welcome to today's KMWorld webinar, brought to you by Vertisia and GraphWise. I'm Mary D. Ojala, Editor-in-Chief at KMWorld Magazine, and I will be the moderator for today's broadcast. Our presentation today is titled Empowering LLMs with a Semantic Layer. And now, let me pass the event over to Grant Spradlin, VP of Product, Vertisia.
Thank you, Mary D. So starting out this presentation and webinar today, we're going to be talking about semantic layers. So I thought it made sense, with so many AI buzzwords being thrown out, Gen AI, LLM, RAG, agents, agentic processing, that I wouldn't want semantic layer to just become another buzzword. So let's set the stage so we know exactly what we're talking about in this webinar. So let's start with the meaning of semantics. Semantics is the study of language, the meaning of language. In other words, the meaning of a word, a phrase, a sentence, or some text. When we're saying semantic or semantic layer, we're really talking about the meaning or the study of meaning. So what's a semantic layer? Semantic layers are not new. In general, they provide a business representation of data that's intended for consumption by end users. And one of the most well-known semantic layers was created by business objects over 30 years ago. For example, the semantic layer for accessing relational databases. Their semantic layer provided a new data representation and query technique to allow information systems and end users to access relational databases without knowing SQL. So that's what their semantic layer did as an example. But let's take a look at another example of a semantic layer. So another example could be unstructured content. Large volumes of business knowledge are contained in unstructured content that's the result of human-computer interactions. For example, someone creates a complex document containing text, images, charts, and tables. That's how the person chooses to best represent and express the information for human consumption. However, another classic problem is that people trying to find this content, they're not going to read the document first to find it. So along came metadata to describe the document so machines could better understand the content and help people find it. As a result, the search is better with structured metadata, but it's still rigid since they often can't search using natural language. Metadata takes care and feeding to fill and maintain it. And software still doesn't have a real understanding of the content. It's just matching on search terms and keywords. The reality is that unstructured business content is purpose-built for human consumption and not for software. When we upload documents into software, and even when we add the metadata, the content is not really understood by machines. So if your users can't efficiently and effectively find and reuse your business content, then I assure you that generative AI solutions and LLMs and RAG will also struggle to find and use the right business content in the right context, leading to misinformation and hallucinations. So let's take a look at why semantic layers are critical for LLMs to understand content. With advancements in generative AI and large language models, software can finally read and reason over human language. So it's logical to think, well, we just give all of this content to AI and now it magically works, right? Wrong, because there's still multiple issues for the LLM to overcome. They have a limited context window for how much data they can accept at once. And yes, context windows for LLMs are getting longer. They call it long context. But again, it's wishful thinking. In general, the more context and content that you give to an LLM, the more noise that it has to deal with for completing a task, which also leads to subpar results. If you pass garbage in, you're going to get garbage out. In this diagram here, I have a complex PDF on the left that contains a mix of text, charts, and tables, and the representation of the information was created, again, for human consumption. This is how we want to represent in the PDF and present these facts. However, when we process this PDF through a generative AI's provider's latest and greatest OCR service, we get the output on the right. And if you look closer, what you'll see is that the image, it's not there. There's just a reference that says there is an image. Some of the text data is captured. You have a couple years, but then you're missing another year. You look at the table has lost all meaning and is going to get all jumbled up. So basically, PDFs were designed to look the same everywhere, but they were not meant to be understood by machines. And if you pass the result on the right to an LLM, then you're going to lose the meaning of this information, and you're going to get inaccurate results and likely hallucinations. So while PDFs are perfect for human consumption, they become a bottleneck for organizations trying to leverage their document repositories for AI and analytics. And therefore, this is just a great example of why hallucinations are happening. So now I'd like to look at semantic layers for documents. Unlike conventional extraction tools that either lose document structure or require manual template creation, and unlike generative AI approaches that introduce hallucinations, Vertisia's semantic layer for documents uses advanced AI only for the analysis and fully maintains the original text. Our intrinsic content referencing method ensures that not a single character is altered, rewritten, or fabricated during the conversion process. So we transform the PDF into structured XML. The promise of XML was to provide a human-readable and platform-independent way to structure and exchange data. By adding an XML layer to PDFs, LLMs and software processes can now understand the true meaning of complex PDFs without losing any information that was intended by its human creators. We can intelligently process each page based on the content of what appears on the page. Maybe one page might be very heavy on text. Another might be very heavy on imagery and tables. We can customize the semantic zone detection. So we can specify exactly what a header is, what a content area is, what the footnotes are, and we never, again, rewrite or modify text. Our groundbreaking approach preserves the true meaning behind the unstructured content. We can process tables, we can describe images, because the images are there to support the text. And if it's a combination of both imagery and text, we can combine the two to preserve that information and also preserve the full content hierarchy. That way you have the right parent-child relationships to understand how the content and how the information was meant to flow. Unlike other approaches, there's no opportunity for software to fabricate or modify the content, which leads to zero hallucinations. So let's take this a step further and look at how these documents can also be used in a semantic RAG pipeline. So I'm going to focus here on how Vertisia utilizes LLMs to semantically prepare content for retrieval augmented generation, or RAG. So first, we're going to extract the text. This is where we can do either a basic text extraction or advanced processing to add a semantic layer that preserves the richness and meaning of complex documents. Next, we use LLMs to read and classify documents based on the semantic meaning of the content, and also to associate schemas, capturing metadata, again, so we can better describe, find, and reuse that content. When we generate the metadata for the document, it's based on the source content. When the metadata is filled, it's done so semantically based on that source content and the business taxonomy. For example, a business might have a standard taxonomy for how they describe their data. LLMs can semantically translate what it reads into those structured values so you still maintain your business-specific labels and values. Many RAG pipelines chunk content into smaller parts for use by LLMs, but the chunking strategy is naive and normally based on a character count. This is another problem that leads to hallucinations because the chunks can lose their meaning when sentences become fragmented thoughts and related paragraphs become separated. Vertisia uses LLMs to semantically chunk content into smaller parts, always retaining its intended meaning. And then lastly, we create embeddings. Vertisia has multiple vector indexes for various embeddings. For example, embeddings on images, embeddings on the text, embeddings on the metadata. Embeddings drive similarity search based on the semantic meaning of that text, metadata, or images, enabling capabilities like natural language search. In the end, business content is decomposed into all of these pieces that one might use in a RAG pipeline. So you can retrieve the right data using the right search tool for the right use case and task. So it's not about just a vector search or just a graph search or a full text search or a structured search. Those are all search tools that you want to be able to leverage. However, it requires the data to be prepared in different formats so you can effectively find that information with the right search to then retrieve and augment your prompts and reduce or eliminate your hallucinations when you do your final generation. That's how you deliver an effective RAG strategy, and that's what we mean here by semantic RAG. We're considering the semantics of the content at every step as the content is being prepared for RAG. So that wraps up this part of the webinar. For more information, you can visit our site at vertisiahq.com. And with that, I am now going to pass the ball over to Andreas from GraphWise.
Yeah, thank you, Grant. That was a great overview already of what semantics can do for organizations, for people, desperately swimming and drowning in information. And it's still the case in many organizations. We are facing underperforming assets. Digital assets are actually containing a lot of valuable information, data, knowledge, anything would be already there, but how to make use of it. And GraphWise has been around with its two halves now being merged into one company for over 15 years. And our mission always was helping customers to govern, integrate, connect, and contextualize the data and content. So knowledge graphs have been around for many years. And now with LLMs in place and the combination of those two elements, we see a lot of interest and a lot of new opportunities for organizations. Let me give you an example. So for instance, just recently, we've been working for a Swedish manufacturer of hydraulic systems. And the hydraulic systems are, as you can imagine, complex machines. If you're a field engineer and you run into troubles, you would love to have quickly some suggestions how to fix the problem. First time fix rate is, for instance, an important KPI. So, but in reality, when you use a very, let's say, simple RAG approach like vector RAG, it just doesn't solve the problem. As Grant has laid out, so for instance, to preserve the document structure is one of the key elements. To understand really the meaning of each and any word more precisely is important. So you really have to build a reference model to make sure all the concepts, the products, the acronyms mentioned in such documents are interpreted correctly. And only then the answers, and first of all, the query of the end user is interpreted correctly, and then the chunks of information can be retrieved from the systems and then generated or used to generate the right answers. And if you make a comparison, as we did with vector RAG and pure LLM, I think that's quite clear what happens when graph RAG is in place. And in that case, the effort being taken to build the graph was relatively small, so it was not a big issue. So you see, it's quite complex task to be fulfilled here. There are different incidence categories. Typically, different queries are associated to those, as you can see. And for the majority of those, graph RAG was clearly outperforming any other RAG system. So the semantic layer was really empowering the LLM, and that's the title of this webinar, I guess, quite a lot. And just to be clear also, when we talk about semantic layer, there are different varieties around. It's not that there's just one semantic layer, one version, one variety. There are types of semantic layers, and I really don't want to try to outplay one of these now. It's all of them have absolutely do their job, but as an end user, as an organization, you should take a clear look at, okay, what type of semantic layer are we talking here about? So I guess what Grant was presenting just before is the good old business intelligence BI semantic layer, which does a great job when we talk about structured data, databases, tables, fine. But as soon as it comes to, let's say, multimodal data, you start looking into graph. And there are two types of graphs out there, LPG and RDF. And so the key difference really is, okay, with LPG, you can get quickly to a solution for, let's say, per silo. So if you have one repository, when you make a rack application on top, which does a better job, LPG might do already a good job. Property graph are rather simple. It's like a bike. Yeah, you can use it without any driving license, and you go quickly from A to B. If you rather want to build on a really rock solid platform and infrastructure in the long run, and bring your organization up to the next level that AI can be used all over the places, and all the data, is it structured or unstructured, doesn't matter. So text or SQL data or semi-structured, like for instance, technical documentation, then you should go for the RDF semantic layer flavor. So that's definitely something worth looking into. That I'm not wasting your time with all the details, but it's this slide just should tell you or give you a taste of, okay, take a closer look at the different semantic layer versions and the varieties out there, because in the long run you have to make the right choice. Okay, so how does that work in the RDF case? So first of all, we are facing multimodal data. So it's really comes in all kind of varieties, structures, semantics. And this is something you should first of all use. All of those contain factual data. Most of the data in there can later probably become part of the answer users are asking. So first step, you need to put a consistent metadata layer on top, which then is obviously enriched by domain models. So domain-specific knowledge, which, for instance, is about hydraulic systems, is mandatory to kind of give the context to the actual or to the data in the repositories, because it's definitely not the case that anything you need to know about, let's say, again, hydraulic systems, is anywhere written. It's still 50%, 30%, depends on the domain, is nowhere written, nowhere stored, in no database in an organization. It's just in our heads. It's still a knowledge which is provided by the subject matter experts. And that can be digitized by domain knowledge models and then gets next to the actual data. And on top of that, so the enterprise knowledge graph then, which is the basis for the semantic layer, brings all the information then next to the graph AI applications. So if you would look at it in more detail, you typically have these types of data, like all kind of, let's say, M365, SharePoint, Adobe, SQL data, any data really. Put the consistent metadata layer on top, which is driven by domain knowledge models like schema, ontology, taxonomies, vocabularies in general. And this all then automates the generation of an enterprise knowledge graph. And those elements put together are the semantic layer, which is kind of really a strategy moving forward to make AI happen at scale on top of all the data you have in your company. And that's what our software can support at many points. Okay, so another example of GraphRag where semantic layer plays an essential role is when you really want to trust that all the answers are just based on factual data, on data you have in your knowledge graph. Then you could use GraphRag flavors like Talk to Your Graph. Yeah, it's kind of a self-service data system. No-code GraphRag is used here, and the trick really is that with help from LLMs, natural language queries are translated into Sparkle queries. So the majority of the population on planet Earth cannot write any Sparkle query, but you can ask questions, and the system in place can translate that into Sparkle queries, and then together with vector search and full text search, you can which you can configure no code, as said before. You can build your own GraphRag-based conversational AI chatbot. And this is really important for many domains where you have to trust that any answer given is based on factual data. So zero hallucination is the goal here. Yeah, so there are different flavors of GraphRag solutions. All of them make use of a semantic layer. All of them use the type 3 semantic layer, but still there are different varieties to that. For instance, you can build a knowledge hub, you can build intelligent support desk systems, automatic compliance checks, for instance, over ESG regulations. They're still around, you wouldn't believe. And yeah, connected content is also a very fascinating use case you can build on top, so people can really understand how things are related to each other, especially in specific domains. This is very important. So to sum up, benefits in a nutshell, self-service success rate is still pretty low. So here, way moving forward is using a semantic layer, typically flavor 2 or flavor 3. 49% of leaders involved, as stated at the beginning, are not happy with the output of their AI projects. Why is that? Because they're just lacking of this domain knowledge typically. So this is what is the missing piece. And then last but not least, it's all about costs at the end of the day. And here again, we need really good that they are in the RAG system, the retrieval part still can lower cost very well. Very much if you do that the right way, and the efficient retrieval methods can be provided with GraphRag. Yeah, I think that's about it. Just one sentence about GraphWise. Just recently merged onto Text and Semantic Web Company. We're one company now. It's not a portfolio company. We have built our tools over the years. Our two platforms got merged into the GraphWise platform. Now a global player in this field, and happy to support you with your journey towards working AI, make your AI and your data and content AI ready. That's our mantra. Yeah, happy to be in this great webinar, and now looking forward to a good discussion, and thanks for your attention.
Well, thanks to both of you. I think we are now going to move into some discussion, and I wanted to start with, I feel, after having listened to the two of you, I feel like I was just in a crash course for Semantic Layer 101, and if either of you decide to become university professors, I will be the first person to sign up for your courses. But I want to bring it over to the area of knowledge management because, of course, as editor-in-chief of KM Magazine, I feel like I should do this. So from the KM perspective specifically, what do you think are the best, or maybe I should say the good, use cases for semantic layers? And I'm kind of thinking this has a great deal to do with preserving the original information. Grant, you want to start us off on our discussion?
Yeah. So in terms of knowledge management, short answer, yes. Knowledge management use cases greatly benefit from semantic layers. It's one of the best use cases even for a semantic layer. And also, yes, the original information, if it isn't preserved, then it raises questions about the validity of the knowledge itself.
Yeah.
And additionally, semantic layers will help users and software find the most appropriate knowledge. For example, using semantic or natural language search. So that's where you need to have semantics and semantic processing in terms of getting the content into your knowledge base or into your knowledge management system, but also leverage semantics when you're retrieving information from your knowledge management system. And if you don't preserve the information as it was originally intended, you're going to get misinformation.
Absolutely. Andreas, what's your take?
So, coming from this semantic space, was always quite picky on what is data management, what is content management, what is knowledge management. And to me, it's still, after 20 years plus or so in the industry, important to bring data and content together into one element. And And I see that again and again. There's the data people and the content people, and they, funnily enough, they just don't work together that much. And we see that all over the places. Organizations now really start to understand knowledge is everywhere. It's in both siloed environments, so to speak, and then within those silos, the even more silos. And so I think knowledge only can really be kind of used that much if we start to link it and contextualize it and deliver it also in a more personalized manner. And this is what knowledge graphs can do really very well. So they really can at scale bring those elements together out of different silos, and then eventually push that in front of the LLM, which then probably helps to summarize it or stuff like that. So I don't think that RAG and LLM will add that much of new knowledge typically to what we have already in our organizations. It would be really good enough if we were just govern, link, and use the data and content we have already in a far better way. What we can do with knowledge graphs and the semantic layer as proposed, and of course LLMs push that and drive it in a very good direction, accelerates the whole topic nicely, and that's very exciting at the moment.
It's an interesting point that all of these various areas, the data people, the knowledge people, the information management people, they're all talking about very similar things, but they're not talking to each other. And the siloization does not seem to have disappeared, even though we keep talking about it. And I don't know whether the semantic layer is the solution to this. I'm not sure at all about that. But what about the other thing you mentioned in your talk, Andreas, was about multimodal. And I think maybe that's one of the things that has changed over time, that when you go back and you look at, well, like records management was documents. And we've moved so far away from that. So what do you see as the advantages to semantic layers going forward with the multimodal types of information?
Yeah, I guess semantic layer comes from the structured side of things. SQL data was predominant in the first phase of semantic layers, which does a great job if you're on that side of things and want to accelerate reporting on top of your business data environment. Great. But as you said before, I mean, it's all gravitating now towards make more out of your assets, bring it even closer to the different stakeholders, to the different people in the different roles. And if you look at just at products, yeah, so let's say you're a pharmaceutical company and you have thousands of different products and different people are involved in the production process, they need to look at it in many different ways. So some data is in the SQL database, some are written in a SharePoint, wherever it is. It doesn't matter. It shouldn't matter anymore to the people. They should be able to kind of get rid of this duty that they have to understand the implicit semantics. Where does it reside? Where's the folder? At the end of the day, people start asking around other colleagues, and and that's probably not the way moving forward. It doesn't scale. So I believe the semantic layer is the only way out of this fragmented world we are living in, right? So we have to have contextualization, context engines. The context engine is the semantic layer, and you can govern it. You can look at it. It's not a black box. It's not calculated based on some fancy statistics. It's something you are accountable for at the end of the day, even if you give a wrong answer. And that's important in many industries. You cannot just trust the AI will do the job for you. I mean, talk to a lawyer. No, I start talking to my ChatGPT. No, this is not a good solution, right?
This is a terrible solution. Exactly. I'm not even sure the word solution is appropriate. Grant.
Yeah.
In terms of semantic layers and multimodal, I think it's most important when it comes to text. Most LLMs are processing text and are still very text dependent. And when you start talking about multimodal, let's say you're going to pass an image too. You might be passing an image along with the text. But again, back to that example where you have the image in the text, right?
Yeah.
If you don't have a semantic layer to explain to the LLM in the context of the text, where is the image and what is the image? How does it support the text? The LLM is just going to get an attachment, doesn't know if it's in the beginning, the middle, or the end of the text, and it's going to get the text. And it, what it does with that is up to the LLM, right? So it just presents an opportunity for the LLM to misinterpret the information because it's lost the meaning of the information.
Yeah.
So yeah, it's really important, and especially when it comes into multimodal, because that's how you provide the context for the LLM of how these multimodal inputs are related.
Yeah. The title of our webinar was about empowering LLMs with semantic layers. So give me some contrast here. What are some examples of LLMs with semantic layers as opposed to LLMs without? And where's the benefit here?
I'm happy to take that one, Mary.
Okay. Go ahead, Grant.
So like when I was describing the semantic layer, right, or multiple semantic layers, and the same with Andreas, right? We weren't necessarily talking about the LLM itself having a semantic layer. The semantic layer is generally outside of the LLM. So LLMs themselves don't exactly have semantic layers per se, although they certainly understand semantics. One trend is where some LLMs have built-in thinking or reasoning, where the LLMs break down the understanding of a prompt and consider multiple approaches to generating a response before they actually send the response. Basically they use additional tokens to better understand the semantic meaning of a prompt. But even if you have an advanced thinking model, they still benefit from semantic layers outside of the LLM, because again, that's how the LLM is going to get the contextual meaning of the input that you give it. So when I think of semantic layers, I think mostly of what's happening outside of the LLM to better prepare the data, present the data, and contextualize the data for the LLM.
Andreas?
Yeah, I think there's a lot of knowledge kind of implicitly found on the document level. If you talk about unstructured, semi-structured data, if you just throw that away and put it into a kind of a vector based format, it's just gone. It's no longer existing, and we cannot expect to get the right answers anymore. That's on the document level. When we talk about silos, how to link those, to be accurate, this kind of knowledge is nowhere written. It's a domain specific knowledge you should have to know how things relate to each other. Reasoning is a different story. I mean, here, just expecting to have reasoning without any kind of symbolic AI, which does an accurate job, is a bit a risky thing, I would say. Because having results every time you use it in different ways presented is not very predictable. I think it does a great job when it comes to kind of maybe be creative, summarize something which is kind of true, and then somebody makes a supervised version out of that. That all works pretty well in the meantime. But I'm really talking about industries where stakes are high. And here, this just doesn't work. You need a layer, a semantic layer you can look at really as a domain expert and say, okay, this is true or this is not true. And if that's not the case, I don't expect any organization to start using that at scale. I mean, just playing around in terms of POCs or so, that's quite normal in the meantime. But to come to a really productive end, the semantic layer has to be governed. You need someone to take a look at it again and again. It evolves with the organization, and that brings us back to people like good old taxonomists. Yeah, they've done a very, very good job in organizing knowledge, and they are not at all obsolete. Yeah, they are even more important these days than ever before.
Absolutely. We have a number of questions that have been lined up here from our viewers. So let me move over into taking some of the questions from our viewers. And again, a reminder, if you do have some questions that we haven't covered, do go ahead and put it into that question box and click on the submit button. So let me start with this one. How much data engineering would be involved to create the base of semantic layers? Grant? You want to tackle
it's a great
that one?
question.
Yeah.
It definitely depends on the software. If you're going to build it, from scratch, I would say there's a lot of engineering that goes into it. I think that's where myself and Andreas, we would probably both agree that that's part of the power of these platforms and the software, right? Is to be able to bring these semantic layers without having to build it and engineer that from scratch. So in the case of Vertesia, our semantic layer is established by the software itself. So there isn't engineering work involved to create that semantic layer. Some organizations might want to configure aspects of their semantic layer. So for example, again, if you have a business-specific taxonomy that you want to use, or there's specific maybe zones or areas that you want to focus on in different types of documents, things that might relate to different groups of content. But that very much depends on the organization and their use case. And in the case of Vertesia, we're talking about configuration, not real engineering development efforts.
Andreas?
It's slightly different to what Grant just said, because we see the importance of well-engineered knowledge models. And it's not like you would ever start on a green field. For each and any industry, there are kind of standard ontologies and taxonomies available. So I've seen in the ask a question box, for instance, one question if there are freely available knowledge graphs. Yeah, tons of. So you can start from there, and then of course you have to add your own specific vocabulary. So enterprises are strategically well positioned because they are not just using the same knowledge as anybody else, right? So they have their own specific knowledge, and you have to add that next to your, let's say, standard manufacturing vocabulary. And this needs to be done somehow semi-automatically. So we use a lot of LLMs also to help create knowledge models, but you need a kind of a supervision still in place to make that correct, because the domain models are kind of the source of truth, which do everything downstream then, or control what's happening downstream automatically. So if you do already the knowledge model wrongly, then this pattern will then be copied downstream again and again. And typically there are hundreds and thousands of users then struggling with wrong answers, etc. So it's really worth paying a lot of attention to the source, because it duplicates then the quality further down the stream. It's like water. Yeah? If you have a problem in the source, you shouldn't drink the water in the cities.
Okay. We have a water main leak right at the moment where I live, so I don't want to talk about water. Here's another question for you two. I'm writing a query to the LLM. It translates to a Sparkle query. Now my question is, how effectively does this Sparkle query work? How can it be improved? Are there any other approaches?
I think I have to take that one because it refers to this.
I think it's referring to what you were just talking about. Yeah.
But this is a great question. It's again, the Sparkle, the translation from natural language query to Sparkle works very well as soon as you start using ontologies like schema.org. Schema.org, you may be familiar with. It's used all over the places. So Google is using it quite a lot for improving indexing, etc. And you can use it also for any other purpose. It's not necessarily bound to a website. So you can use ontologies like that for many enterprise data repositories to just put more of a meaning and semantics on top of it. And then these ontologies help to translate the NLQs, the natural language queries, into a query language like Sparkle, which then really retrieves just those facts, those parts of this sometimes really massive knowledge graph. So it could be billion of triples and facts in such a knowledge graph. Think about pharmaceutical, and it just retrieves those elements which are really relevant to the query. It's not just Sparkle again, so it's really also a mixture of Sparkle and vector search, but that works very, very well. And you can incrementally improve the quality, of course, stepping back, okay, wrong answer given, looking into the knowledge model, change that, fixed, done. So you don't have to retrain your model, your LLM or something like that, which obviously costs a lot of money.
Yeah, sure does. Grant, anything you want to add to that?
I think Andreas summed it up pretty well. That's more his space for sure.
Yeah. Well, we do have a question for you, Grant. What are the biggest challenges in extracting meaning from unstructured data?
So I think the biggest challenge with extracting the meaning is extracting the meaning. So it
sounds a bit circular there.
Yeah. But if it's a simple flat text document, great. Just take the text. You have the meaning. But as soon as you have any type of hierarchy in that content, as soon as you have any type of mixture of something that's not text in that content, you risk losing the meaning, and it's very important on how you approach that to extract the real meaning. Otherwise, otherwise you're up a creek without a paddle.
Yeah, you really showed that in your slide about the PDF and what happened with the data. It just kind of became unusable and even basically disappeared.
And Mary, from my perspective, I've been looking at business content for many years, and that's what's typical. That's what's representative of real business content that's out there. It being text only, without images and without graphs and without tables. I mean, that's how people express information, and they put together their thoughts. So we need to be able to handle those constructs and give them appropriate semantic meaning within that text for the LLMs to do their job.
I'd like to add one element. So I totally agree, but one additional, let's say, it make the extraction of meaning is tricky also because it's not necessarily always 100% clear what's there. So it can be ambiguous. It can also mean for different people different things. Language is just not completely. It can be interpreted in different ways. It can be ambiguous. And I think that's also important in such engines that we start to link meaning to roles and people in their context. So think of health information, for instance, if you have a self-service portal in healthcare, the same text, the same, in structure could mean different things to people in different, let's say, life stages when they have different history, right? So they have to interpret it in different ways, and systems should help them to understand it the way they should understand it. So this is also something we should be very clear about. We are not engines, and there's no such a thing like, not even for engines, the manuals are always 100%, accurate. It depends on who is reading that, and we are not ending up getting digitized by ourselves. It's not possible.
Yeah, and what is their level of knowledge going into trying to read a manual?
Right.
Are they? Yeah. It may be a 200-page manual, and you may be an expert in the field, but going through 200 pages is still a challenge.
Yeah, language is a tricky thing. So we're just, the same thing can mean multiple different things. So we were just prompting a model earlier about something related to GTM, right? And the model comes back and says, "Oh, let me tell you about how this relates to Google Tag Manager." But we were not talking about Google Tag Manager. We're talking about go-to-market, right? So the meaning was totally lost because the LLM didn't have the additional context for what we meant by go-to-market. So easy fix, but just an obvious example of how language can be misinterpreted even when it's intended to be clear by kind of the human operator.
Particularly when it's an acronym.
Especially with acronyms. Acronyms are very tricky.
So when you're looking at training a semantic layer, what is actually required to train or to establish a semantic layer? This is my back to basics question.
I can start. Typically, we start with a conceptual model. So you can think of a kind of a bit of a more sophisticated mind map where, let's say, you scope out the business domain, right? And with that in place, you can enrich it step by step with help from LLMs, from corpus analysis, from transformers we use again and again. And you just start to enrich the domain model. And then you can do a lot of automatic steps to create this entire semantic layer, which ingests data from the repositories in place, which obviously contain a lot of data in different formats, multimodal data. And this is all bound back to the conceptual model then, and is can be queried by using graph databases, which should be obviously high performant. And that's how you create that step by step. So I wouldn't say you train it. It's more a task to be fulfilled by knowledge stewards together with knowledge engineers.
I think Andreas summed that up perfectly in that last phrase. It's not a matter of training. It's a matter of administrators configuring and setting up the specific business information that you want to use, and it really depends on what form of semantic layer you're talking about. So like when I talked about a semantic layer for documents, that one doesn't really require you can optionally configure and provide additional information, but you don't have to. It just works. We read the document and we add on the semantic layer using our approaches that we have. But if it's about a semantic layer that involves your business taxonomy, like Andreas was talking about earlier, right? Your metadata, your master data, of course you need to set that up and configure that, so that it's being used in the appropriate places within your semantic layer.
We have a viewer question here of, would it be fair to say that on the very low levels of the semantic layer, it's best to use any form of a data lake, and the graph database would connect to these data lakes and facilitate as a taxonomy layer, driving and guiding the LLM to get data?
Yeah.
That's a very complicated question, but yes, go ahead.
Yeah, that's kind of, I would say, already formulates several elements of how things work. The data lake, the data layer stays where it is. No change in governance here. It's first of all, this consistent metadata is lacking typically. It's just not in place. So each silo has its own metadata, governance model, or even no metadata. So there's just, randomly just pushed in front of the LLM or retrieved by some, let's say, magic kind of data engineering tasks is lacking completely the business knowledge. Yeah. So if you have no subject matter expertise when building the semantic layer, and it's just a replication again of what's anyway already in the data lake, it's really garbage. I mean, I wouldn't say that the data lakes are garbage. It's just data lake to data lake. So you can skip that step. Either you add something more to the data lake, or you just don't do it anymore. It doesn't matter. It doesn't really help you to create any additional value. So why not spending, let's say, 1% of the costs you already spent on creating all the data content in different repositories, just 1% to have good metadata and some additional knowledge models on top. You leverage the value of your data that much that I just still don't get it after having been 20 years in the business. That organizations is a no-brainer to me. I mean, of course, there are many out there in the meantime doing that, but they still, grapple around on the data layer and try to fix some problems there and now hope that the LLM is going to do the rest. And it doesn't.
Grant?
Yeah, I mean, when you have a lot of data, organizations tend to put it in a data lake. But I would say, it doesn't prescriptively need to be in a data lake. Your data, especially when it comes to things like the unstructured content, right? Generally, that stuff's scattered across all different locations, file shares, and different applications and things like that. So yes, it helps to consolidate data and content when you need to integrate it. But I wouldn't say that it necessarily has to be prepared in the form of a data lake. To Andrea's point, the most important part is that you're giving that information wherever it lives semantic meaning, and using the semantic layer as a method to provide additional context about the information that you have in that data lake or application or wherever your data lives.
We have a question here. I think it's related to the conversation we've just been having, which is how do you ensure that the semantic layer stays consistent and up to date if the underlying data changes?
It's definitely, for instance, let me give you an example. A regular corpus analysis. So if you have a lot of documents, let's say in your CMS, so doing it on a regular basis, corpus analysis means you just screen the space if anything new has popped up. So that's something you do quite automatically, and you suggest, for instance, new concepts out of the document. So let's say 5 years ago, probably coronavirus would have become a new top candidate to get added to your domain knowledge model in many industries, right? 10 years ago, nowhere. Yeah. And you can do that again and again, same workflow. And then as soon as you have that in your controlled vocabulary, in your taxonomies and ontologies, it's used then all over the places. Yeah, it's contextualized the right way, hopefully, and then it got the meaning. So when we read COVID-19, we have a lot of information around it, what it is, what it causes. Yeah, of course, that was a fast-moving topic, and someone had to work on that to make it, updated again and again. Of course, you can let machines do that. They just try to get some kind of meaning out of the news articles and out of the databases. But this will never reach the same level as you were someone else who has the domain knowledge doing that. Of course, it can be a collaborative workflow. It's not necessarily one person only who is the one who says what COVID-19 really is. Yeah, we don't want to have that kind of ontologies. It can be a collaborative effort, and people and different subject matter experts can work around it.
Yeah. You wanted to add something, Grant?
Yeah, sure. One reason why your semantic layer and or your underlying data might be changing is that businesses update and change taxonomy over time.
Right.
Maybe some companies get acquired. Maybe the business perspective changes a little bit. Maybe new data is needed to better describe information. It's just part of the evolution. But that's a very traditional content and digital asset management challenge, to be able to introduce new metadata or change metadata, because either it requires an army of people to manually re-enter metadata, which just isn't going to happen. Like, it would need to be very, very valuable information to warrant the cost of that.
Yeah.
Or you need to have engineers write migration scripts and things like that. So in our platform, though, we solve that problem very, very simply. And it's very easy to update the configuration and to reprocess content to adapt to those changes, because we're using the LLMs to semantically fill the metadata. So if we need to change the definition, or we need to add a new definition, brand new metadata or taxonomy that didn't even exist, now we want it because it's business critical, it's very easy to add that and layer it onto the content that you already have, without requiring an army of people or major engineering efforts.
Let me clarify probably one thing. That's a common misunderstanding, I guess, that metadata has to be done, as Grant said, with an army of people. No, not at all. Metadata always has to be done automatically. Otherwise, the whole system would never ever scale. There's just different ways to do that. And one way is just using these elements. You remember the semantic layer has domain models, and they are very small compared to the rest. It's like not even 1% of the rest of the data. And this, as I said before, that's the source of truth. So if you take it from there and then run, for instance, the tagging process automatically based on the models, you do a lot of stuff automatically. But this little model, this little part of the semantic layer, the models, that cannot be done automatically. Still not, and should never be done automatically, because then nobody is accountable anymore for anything.
And I would like to thank our speakers today, Grant Spradlin, VP of Product for Vertesia, Andreas W. Blumauer, SVP Growth GraphWise. Thank you again for joining us today.